What we can see is we have brackets on the left and a difference of 2 squares on the right. We are not going to do anything on the right-hand side. Our aim is to write it in standard form. So have all the terms on the left equal to 0 on the right. So first, let us multiply out. And I identify these sets of brackets as a difference of 2 squares. So when I multiply it out, I'll have x squared minus 9 minus 1 is equals to 4 minus x squared. Now what you can do is you can add up like terms. So you'll have x squared minus 10 on the left and 4 minus x squared on the right. And what I would like to do is move all the terms to the left hand side. So I have x squared plus x squared. So moving this negative x squared becomes plus x squared. Minus 10 minus 4 equals to 0. And if I add like terms together, I have 2x squared minus 14 is equal to 0. Now this is a slightly different solution. What I can see here is I have a common term of 2. So I can divide everywhere by 2. So if I divide 2x squared by 2, I have x squared. And then minus 14 divided by 2 is minus 7 equal to 0, which is the result of 0 dividing by 2. Can you see that I applied the same calculation on the left to all the terms on the left and to all the terms on the right? Now, some of you wouldn't have seen this type of question before, but this is actually a difference of 2 squares because we have 2 terms and a minus in between. So we have x and x, plus and minus, but this is not a square number, but we can create the square by taking the square root. So if I want to factorize x squared minus 7, it will become x plus the square root of 7 times x minus the square root of 7. Now, in order to find the values of x, I will take each set of brackets and set them equal to 0. So x can be equal to negative square root of 7, or x can be equals to plus the square root of 7. And both of these answers are valid. Remember, you're not allowed to have a negative number inside of a square root, but the negative can be outside of the square root. So therefore, both of these answers are valid solutions.